Dear students, we are discussing about the types of stresses. In yesterday's class, we have seen um, about the torsional shear stress towards the end, and this is the formula that we were using. Tau upon R is equal to uh, T upon IP is equal to G theta upon L. Sometimes this IP is written as J also, capital J. So where tau is a shear stress. See, shear stresses are always mentioned with this Greek letter tau, whereas direct stresses are all represented by sigma, small sigma. Okay, and this is the radius. This is the torque or twisting moment, and IP or J. This is the polar moment of inertia, and G is the modulus of rigidity, theta is the angle of twist, and L is the length of the component. So from this, taking the first two terms here in this torsion equation, we can rearrange them like this. Tau is equal to uh, torque into R by IP. So this is the formula that we'll be using while designing a machine component which is subjected to torsional shear stress. And mostly torsional shear stresses are subjected to cross sections which are circular. Okay, here we'll be seeing only circular cross section. It can be um, hollow section, hollow circular cross section, or it can be square, it can be rectangular, or anything. You see, once we know what is IPP, IP, that is this one, then you'll be able to find out whatever. Only this formula, you should keep in mind. Okay, if it is a circular cross section, this is R. This is a diameter by 2. If it is the square cross section, this will be um, y, that is distance of the extreme fiber from the neutral axis. Okay, so when we solve the problems, the idea will be more clear how to find out the diameter using this formula or whatever the dimension. If it is a square one, the side you have to find out. If it is a rectangular cross section, you have to find out the length and breadth of the section. Okay, so here another case is there um, for a hollow circular cross section, but at the present we need not see it. Okay, so coming to the next stress, this is the bearing pressure and crushing stress. Okay, uh, bearing stress, crushing stress. I say the definition is like this: a localized compressive stress. You see, I told you yesterday what is the difference between a localized stress and a body stress. A localized stress is only at the point of contact on the surface or to a small region. It is restricted to a small region, then it is a localized stress. If in the entire body it is there, then it is called a body stress. So this stress is a localized compressive stress at the area of contact between two components. So here this stress to be existing, there should be a contact between two components. Two components should be there. And having relative motion between them. You see, when we are talking first about the bearing pressure here, relative motion between them should be there. Relative motion means what? Relative motion means what? Suppose you are in a train sitting and the train is going at a good speed of 100 kilometers per hour, but you are sitting on the train. Okay, so are you moving or not? You are moving, but your motion with respect to the train, if you see, Train is also moving at 100 kilometers per hour. You are also going at 100 kilometers per hour. And if you say what is the relative motion between you and the train, then we say it is zero, because though the train is moving and you are seated on the train, but there you are not moving in the train, you are not walking in the train, so your motion is zero with when you compare with the train. But when you compare yourself with somebody on the platform or on the side of the railway track, then you say, oh, you are moving at 100 kilometers per hour. So that is the difference with respect to what you are saying. Okay, if two components, if they both are moving, you see in the cycle you have pedal. That pedal is fixed in that pedal rod. So the pedal rod and pedal both are fixed, and in the pedal rod also the axle will be there, and there will be a what you should say, a cotter will be there. Okay, so the cotter is fixing the pedal rod to that axle, and it is we insert it, we hammer it with a we hammer it inside and then put a nut and tighten it. Okay, once it is tightened and we are traveling, the we are cycling and going forward, then what happens is we are moving forward. That pedal rod also is moving, rotating. But if you say, and the cotter also is rotating, the axle also is rotating. Okay, but if you say whether the cotter in the cycle, pedal rod and the pedal rod, are they moving with each other? No, there is no relative motion between them. You're understanding what is the relative motion means? ये दोनों के आपस में कुछ मूवमेंट होना चाहिए. अगर आपस में मूवमेंट है तो रिलेटिव मोशन है, आपस में रिलेटिव मोशन नहीं है, मतलब हिलते नहीं है, तो इनके बीच में रिलेटिव मोशन नहीं है. This word relative is important here. Whenever you are defining bearing pressure, this relative motion should be there. Okay, so the localized compressive stress at the area of contact, where at the area of contact between the two components having relative motion between them, this is known as bearing pressure. Okay, the example of bearing pressure is stress between bush and pin of the bush bearing. I will show you a figure in a little while. Okay, now let us come to the crushing stress. So here there is a crushing stress. This is again a localized stress, and this is also compressive stress. The earlier one also, bearing pressure, also is a compressive stress, and that is also localized compressive stress, and that is also at the area of contact between the two components. But here the definition changes, having no relative motion between them. See, in the first case, in case of bearing pressure, there is relative motion, and in case of crushing stress, there is no relative motion between them. This is the only difference. Okay, so if there is relative motion, then it is bearing pressure. If there is no relative motion, then it is called as crushing stress. Okay, so everywhere, suppose you are sitting on a chair. Okay, are you moving in the chair? Mostly no, you are simply sitting. Okay, so what type of stress you are putting on the chair? It is a crushing stress. It is not a bearing pressure. Okay, so the example of crushing stress is between key and the shaft. Now you should know what is key and shaft. Okay, don't worry, we will see later. Okay, now come here. You see, there is some cylindrical rod. Okay, this is represented in the side view with this smaller circle inside. Okay, and then this outside there is a hub or boss of the pulley. Okay, so this inside one is the shaft here. This is also, we call it as shaft, a cylindrical rod. Most of many times we use it as shaft whose diameter is d. Okay, so this inside one, this is the shaft, and the outside one is the, okay, you can say it is a boss, or it is a hub of the pulley. This is the pulley. Actually, pulley is further extended, or it can be some other thing. It is not a pulley actually, because it is not on the other side also. Okay, so you say some connecting rod. This one is a connecting rod with a hole inside. In the hole we have inserted this thing. Okay, and about this circular rod, this one, this moves like this. Okay, is there relative motion between these two? That means one is stationary and one is moving. Is there is relative motion? Yes, there is relative motion. Okay, so here in this case, in the contact area, that is this lower side, this where this semicircular portion, I'm not saying only semicircular because it may not be touching on the upper side, because there may be a little gap on the upper side, which is called as clearance. Okay, so here in this semicircular portion there will be contact. So here a localized compressive stress will be used. This localized compressive stress, now we have to decide whether it is crushing stress or bearing pressure. But because there is relative motion between them, this is called as bearing pressure. Okay, I will explain it to you in a better way here. Okay, now come here. So this is the definition of crushing stress. This definition you can know, you can have it by heart, पाठ कर लेने का. क्या 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 है इसमें? ये लोकलाइज्ड कंप्रेसिव स्ट्रेस है. लोकलाइज्ड बोले तो पूरा बॉडी में नहीं रहता है, सिर्फ सरफेस के ऊपर रहता है. द सरफेस ऑफ कांटेक्ट बिटवीन टू मेंबर्स, यहाँ दो मेंबर होना जरूरी है, ऑफ ए मशीन पार्ट दैट आर रिलेटिवली एट रेस्ट. दिस इज एट रेस्ट. ओके, दिस थ्री थिंग्स, ये तीन चीजें जो है ना होना जरूरी है. क्या है? टू मैकेनिकल कंपोनेंट्स होना चाहिए, और दोनों के बीच में कोई रिलेटिव मोशन नहीं होना चाहिए. ओके, और तब ये सरफेस के ऊपर जो आने वाला जो स्ट्रेस है उसको अपन बोलते हैं क्रशिंग स्ट्रेस. समटाइम्स क्रशिंग स्ट्रेस इज कॉल्ड एज बेयरिंग स्ट्रेस. ओके, actually in the above book it was shown bearing pressure is shown as bearing stress. That is not correct. Bearings, yeah, you see, crushing stress is bearing stress. Crushing stress or bearing stress. Okay, now for example, here you see there is one plate here, down also there is one plate. Okay, we have put rivet, and it is not only one rivet, it will be a line of rivets in a sheet. Like up there is one sheet, down there is one sheet, a line of holes, and in that line of rivets will be put. Okay, so is there relative motion between this rivet and this? Is it that it is turning about inside or something? No, this doesn't rotate. If this doesn't rotate, then it is a crushing stress or bearing stress. Okay, now how to calculate the value of this crushing stress? This crushing stress, for crushing stress also the formula, same formula we will use. What is that formula? Sigma, that is stress, and the suffix we will use CR. Sigma CR is equal to load upon area, that is P by A. P is, this is the P here and here, whatever P we are applying, that is the P. And what is the area? Actually, for area, you see, as you are pulling this side and the rivet is stationary, so this semicircle side only, this and these two will come in contact. Upper half of the plate, upper plate and the upper half of the rivet, these will come in contact. So that means what? See, this half of the half here. Okay, suppose that is A, that is the length of the rivet within this plate A, that is A, and D is the diameter. Diameter means this is the diameter of the rivet. So here actually semicircular, it will be in contact, but okay, anyway, in some portion it may not be fully in contact, some portion it is may be fully in contact. Okay, therefore while area we are calculating, we make an approximation that this is the projected area. Projected area means what? Just you take the length and breadth of this rectangle. We are not taking the semicircular portion. If you take the whole circle is says this is circumference is pi d, and in that case it should have been pi d by 2. Okay, but here we don't take like that. We take only this d into a. So crushing area is, this word is important, projected area in contact, that is d into a. Okay, so for the upper portion d into a, for the lower portion d into b. Okay, and example of crushing stresses is riveted joints. Okay, now the bearing pressure, what we studied earlier, bearing pressure, what should be there? This is also a localized compressive stress. It is existing at the contact between two members, two parts. One part should be in relative motion. Relative motion existing. Okay, it exists. Okay, and here also they are mentioning it is not bearing stress. In the first thing, no, by mistake they have written as bearing pressure as bearing stress. Actually, crushing stress and bearing stress are same, and bearing pressure is something different. Okay, bearing pressure, again here, if you come here, we see here two mechanical components should be there in contact with each other, and there should be relative motion. In the previous thing there is no relative motion. There should be relative motion, and at the surface the localized compressive stress that is being used is bearing pressure. So here, for example, here we are seeing the outer, there is a bush, inside there is a shaft, and as I told you, there may be a clearance existing here, so only the lower portion will be in contact. Okay, so but here no, the shaft is rotating or the bush is rotating, any one of the two will be will be moving, so there is relative motion. Here also, what is the stress? How do you say bearing pressure? Bearing pressure, no, you write P, small p, and suffix B. That is bearing pressure. Bearing pressure is load upon area. The same formula. See, all the formulas are same. Whether it is for tensile stress, crushing stress, or transverse shear stress, and uh, um, compressive stress, and this bearing pressure, all P by A. So here P we know, whatever is the load, the force acting there, and the area, bearing pressure area also, here also we take the projected area. Projected area means, if you project a cylinder, how it will appear? It will appear a rectangle. So the projection of a cylinder is appearing as a rectangle. That's why this is called as projected area. So whatever is the contact length, this much is the contact length, so that much length, and this is the diameter, these two. So projected area in contact is d into L, where d is the diameter of the okay, here it is not rivet, it is the diameter of the shaft, and length is the length of the surface in contact. Okay, this is how the crushing stress and bearing pressure are calculated. Okay, so these are the different types of stresses that we wanted to see according to the initially what table I have shown. Okay, we'll stop here. Thank you.